This project pulse width modulation based power inverter. Its power rating is 1400 watts and supply DC voltage is 24 volts. Output is 220 volt AC. In this project at present we are using 6 lithium cell batteries to provide 24 volt, and power supply is connected by this 2-pin lead. 220 volt AC is generated by converting 24 volt DC to 24 volt AC, and then step up done by this transformer. This transformer convert 24 volt AC to 24 volt to 20 volt AC. To convert 24 volt DC into 24 volt AC, we are using MOSFETs. There are 12 MOSFETs in the circuits. These MOSFETs drive this transformer on and off. Its frequency is 50 Hz. It means in 1 second it will switch on off 50 times. This circuit is total control circuit. To generate 50 Hz square wave, we are using SG3524 IC. This IC has 2 channels, and these 2 channels are supplied to this MOSFET card, and there are 2 channels. Each channel comprises of 6 MOSFETs. By providing DC supply to this IC, it will generate 50 Hz pulses, and these pulses drive these MOSFETs and in turn will generate 50 Hz DC at 24 volt in this transformer primary windings. Secondary windings will step up to 220 volt AC. Its voltage can be controlled by this variable resistance, and its frequency can be controlled by this variable resistance. The power inverter is automatic. Initially I am showing you by switching on, this is the inverter circuit, by switching on this circuit 220 volt AC generated, and this 100 watt LED bulb is on. Now I am connecting this lead to 220 volt supply, and by switching on AC LED, this bulb 100 watt bulb switch on. At present we are switching off inverter switch and only switching on AC switch. So output is AC, directly AC. If I switch on this circuit also, it means we are switching on inverter and main circuit both, main switch both. But as main supply is available, it will supply directly to the output, to the load, to the electric bulb of 100 watt. If I switch it on, it automatically switches to inverter mode, and inverter will supply the 220 volt AC. When power restores, it will automatically shift it to 220 volt AC. Here is the transistor that operates this relay circuit. This relay automatically change our from DC to AC mode, from inverter to directly mains mode. A 220 volt AC operated SCR based, SCR controlled rectifier circuit is also incorporated in control circuit, and this circuit charges batteries when this equipment comes in mains mode. In mains mode, it will supply AC to bulb, and at the same time it will charge batteries. At present we are using lithium ion batteries. These are small batteries. We can connect up to 100 ampere batteries. Thanks.